okay, this one, we gave it a name yesterday. It's called a quotient. And this one, it is called a factor. It is a factor. And this one is the remainder. Is the remainder. Yes. So what does long division help us with polynomials? Remember yesterday I said it is able to help us either to factorize or to solve polynomials. Let's do one polynomial where we'll be able to factorize. So we're going to write here one polynomial. So it says factorize completely. It says factorize completely, which is x to the power 3 minus 3x squared minus x plus 3. Given that x minus 1 is a factor. So if we are given that x minus 1 is a factor, it becomes a little bit simpler because, sorry, I'm just adjusting here. It becomes a little bit simpler. So the first thing that I would do is I'll do a long division. So I'm going to create a long division sign. I'll put x minus 1 here. Then here it's x to the power 3 minus 3x squared minus x plus 3. So now I am going to do long division because I'm told this one is a factor. So I'm going to x into the, so it's always the leading into the leading. So x to the power 3 divided by x, I get x squared. The next step, I multiply, so I'll get x to the power 3 minus x squared. So always try to write the variable on top of similar variables on top of one another. It makes it simpler to subtract. So x minus x, so the leading variables will always give us a 0. So minus 3x squared minus minus. Here we must always make, the reason why we put brackets is so that we don't confuse this minus sign that it belongs to this x to the power 3 only. This negative sign affects the whole bracket. So we are going to check now. This minus goes. So this becomes a positive. So minus 3 plus 1, it gives us minus 2x squared. Minus x minus nothing disappears. So it becomes minus x plus 3 because we don't have any variable to affect this. Now we repeat the same process. X into minus 2x squared, it becomes minus 2x. Come back and multiply, minus 2x squared, plus 2x. Right. I always put a negative. So this negative will always give a positive to give us 0 for the leading variable. So minus x minus 2 is minus 3. X. 3 minus 0 is plus 3. We go again. X into minus x to the power 3, I get minus 3. Then I come and multiply, it's minus 3x plus 3. So if I get this, it is equal to 0 if I subtract. So if you check now, we have 2 variables that, so it means if this is a factor, this is also a factor. We're saying it is a factor of this long polynomial. So it means I can now say x minus 1 factor of x squared minus 2x minus 3. This will give me this if I expand it. But I'm interested in what? In factorizing. So now I'm going to factorize further. I know how to factorize a quadratic expression. And this one is already in a factor. So it's x minus 1 factor of, so I open 2 brackets, becomes x and x. So how do you factorize? If the factorizing, we've done it in grade 10 or grade 9. So this becomes minus 3 plus 1. Then I have completely factorized. Right? Let's say they said solve. Now by solving, it means if we are solving, then we would say this is equal to 0. if this is equal to 0, then it means that we are saying x minus 1 is equal to 0, and x minus 3 is equal to 0, and x plus 1 is equal to 0. What does this imply? This implies that x is equal to 1, and x is equal to 3, and x is equal to -1. I have solved. So I can first divide. If I'm given one factor, right, I can first divide this polynomial and get a quadratic expression, which we are all familiar with. Then now I can come and completely factorize. And if I'm asked to solve, I can now solve from my factors. So sometimes you will not be given this factor. I mean this factor. They will just say completely factorize this. So there is a way you will be able to understand and come up with a factor and factorize. But that was yesterday's lesson. Today, let's go into today's lesson so that we can see what we are supposed to be doing today. Right. Today, we are doing analytic geometry. Analytical geometry. Right. So geometry involves we're talking about points on a Cartesian plane. We measure their gradients, we measure their equations. But today we want to talk about the equation of a circle. We want to talk about the equation of a circle. So the first thing that we need to know is, what is a circle? That's the first question that we must ask ourselves. What is a circle? And right, so a circle is a set of points. A circle is a set of points. Just put it here now. A circle, I'm just going to use this quickly. A circle is a set of all points right. A circle is a set of all points. I'll put you just now. A circle is a set of all points that are equidistant from a given point, right? So a circle is a set of all points that are equidistant from a given point. So if we have one point, right, it means if I am going to create a circle, it means I must have, if this is going to be 5 centimeters, this, if it's also 5 centimeters, it is part of the circle. If I have another point here, which is 5 centimeters, it is also part of that circle. So if we now check now, we have an infinity number of points. Sorry for my circle, but I'm just drawing it for illustration purposes. We have an infinity number of points, right, that are equidistant. So if we now join these points, we create what is called a circle. We create what is called a circle. But now this distance now is a special name. It is known as a radius. I think we all know that. And if it goes up, it goes 2 radiuses becomes a diameter. I mean, it's common knowledge. We've done it through our primary school. What we're interested now is to find the equation of the circle. So the first thing that we want to note is, what is an equation? That's the first thing that we would want to know. What is an equation? So in an equation is a relationship between important variables of a shape or a property or a line that we want to know. An example, the equation of a line is in the form y is equals to mx plus c, where c is the y-intercept and x variable we're looking at. Basically, we're looking at if we are to get to a point, how many steps do we move of x in relation to y? That's what we are interested. So if we come back to a circle now, I'm going to draw using this one, which is a little bit light, brighter. If we come back to a circle, I'm going to draw the circle this side. If we come back to a circle, let's look at this circle, and we're going to draw our axis. This is 0 and 0. So this is a Cartesian plane and x. So this is the y-axis, this is the x-axis, right? So what properties are we interested when we look at a circle? We are looking at how far is each point from this. Let's say our circle has a center, which is the origin. So we are looking at how far is this point. So let's call this point x and y. If we call this point x and y, right, where this becomes our radius, right, because the radius is the distance from the center to the circumference, right? But in literal sense, if you look at it, this x and y, it means I've moved x steps. I've moved x steps going this way, and I have moved y steps going up. So it means I've moved how many steps? X steps up to here. And what I'm saying is, if you are asked to move to y, to this point, and you don't know how to move to this point, you can first move x steps going this way and move y steps going upwards. So this forms a right-angled triangle. So by forming a right-angled triangle, we can implement what is known as the Pythagoras Theorem. I think we are all familiar with what is known as the Pythagoras Theorem. Look at theorem. Sorry for my handwriting, right? The Pythagoras Theorem says the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So in this case, this is the opposite because it's the right angle triangle. So this is the opposite, this is the adjacent, and this is the hypotenuse. This is the hypotenuse. So we have the adjacent, the opposite, and the hypotenuse, right? So now, we are now, in this case now, what is our hypotenuse? Our hypotenuse is r, so it's r squared. Because following this, we're just looking at the relationship of this triangle, is equal to the opposite squared, opposite, which is y squared, right? And now we also look now, plus x, which is the adjacent, which is x squared. So this, we are saying this is the relationship that we can create from a circle. So this becomes the equation of a circle with center 0 and 0. Right. So that's basically, so we can rewrite it as x squared plus y squared is equals to r squared. That is the equation of a circle with center 0 and 0, which is the origin. Right? So, but normally the center of the circle, the equation, the circle does not normally, revolve around, what's the name, the origin. We can have a circle that it can be drawn somewhere here, and we have the origin here. So this circle has center A and B. We are going to look at this circle when we come back again, so that we will be able to see how can we create the equation of a circle without the center being the origin. And even here, I can actually read the origin of the center, because when we create our equation of a circle, we will be able to read by just looking at the equation what is the center of the circle. Maybe it's worth 2 marks, but it is important. So sometimes if you are just given a point and you're told that it is on the circumference of a circle and it passes through, the center is the origin, you will be able to create. I could have done an example now quickly, but my time is up. I will continue tomorrow and give you a couple of examples. So thank you very much. Don't forget to follow us on our Facebook page, and you just use hashtag lockdown. Thank you very much.